Hello friends, welcome you all on my video lecture series on solution of partial differential equation. These days we are talking about the solution of partial differential equation of order 1, and the method that we are talking about, Lagrange's method. So previous than this we have already discussed about the Lagrange method type 1. In this lecture we will talk about the Lagrange method type 2. So it is required to study type 1 first if you are talking about the Lagrange method type 2. So let's see what happens in this method. This is Brijesh Kumar Jha. Welcome you all in my video lecture series. So first we see what happens, what is going on in the Lagrange's method. So once we find the general solution of linear partial differential equation of order 1, like capital P plus capital Q is equals to R, where these capital PQR are the function of x, y, and z. The solution of such type of linear partial differential equation that can be defined in the form of uh, phi UB is equals to 0, where U and V that can be found by the solution of subsidiary or auxiliary equations. Phi be any arbitrary function. So UB that can be obtained by the having the solution of auxiliary equations. Auxiliary equation can be written as in the form of from the equation that you can see given linear partial differential equation. So the auxiliary equation can be written as dx upon p is equals to dy upon q is equals to dz upon r. So this is most important that we have seen in the type 1 method as well. Now let's see what happens in the type 2 method. So before starting the solution, we definitely know we should know that the type 1 is applicable for the finding of u, and for v we will apply the type. So the question given here, p plus 3q is equals to 5z plus 10y minus 3x. So first we get the auxiliary equation that can be defined here. Capital P is 1 here. If you write capital P is 1, capital Q is 3, and this part, the right hand side, 5z plus 10y minus 3x is what? It is your capital R. So after obtaining this auxiliary equations, what we do, we select any two factors, any two fractions. So dx dy that we have selected, suppose. So by selecting these two, what we get, dx upon 1 is equals to dy upon 3. So very easily we can solve this. So it will be what? By integrating y minus 3x is equals to c1. So what we see, the first solution that you can see, the u of x, y, z is equals to c1 that we have obtained here. Now our next part is to find the v. If we go in the same pattern by selecting any other two fractions and get the solution, so that will be type 1 solution. But what we can see, by selecting first and third or second and third, it is not feasible to get direct solution. What we do, we get this relation and then we will apply in any two fraction. So what we can see here, now we select first and last fraction. You can select any second and third also. So here we have selected first and last fraction, first and third. So what we get, it is dx upon 1 is equals to dz upon 5z plus 10 c1. C1 how we obtain here from the y minus 3x from the first solution. So that can be applicable. So by applying this, what we have, it will have the other function of x and z only. Now we can integrate it. So by integrating, what we get, x is equals to 1 by 5 log 5z plus 10 c1. And power. Okay, so what we get here, this we can take this side. So x minus 1 by 5 log 5z that we can get here. So ultimately it is what 5x minus log 5z plus 10y minus 3x that we can obtain here. So by obtaining this, this will equals to C2 we can write here. So thus we get the two solution, and the required solution that we can write here, phi ub is equals to 0. So this is your u, this is your whole term, that is v. So phi ub is equals to 0, and phi is what, and any arbitrary functions that we can define. So in this way we can obtain the solution of such type of differential equation, partial differential equation, using Lagrange's method type 2. So let's see few more examples. So it will make you clear about the type 2 application of type 2 method. So now our question is that is given as here z square plus xy px minus qy is equals to x to the power 4. So in such questions, what we can do, we can arrange in the form of capital P small p plus capital Q small q is equals to r. So by arranging this, what we get here, we have the auxiliary equation dx upon a capital P. Capital P is what? It is a coefficient of small p. So you can take here x multiply here xz z square plus xy. So that we have written here. In the same manner that you can write dy upon this minus yz z square plus xy. And the last term, very easily we can write dz upon x to the power 4. Again, what we can see here, that if we select first two terms, first two fractions, so z square plus xy will be cancelled, z is also cancelled, so only we will have dx upon x and dy upon minus y. So by having this, we can get easily very quick, we can get the solution. So by integrating, it will be dx upon x will be log x, dy upon minus y will be minus log y, and here log c1 that you can take. So ultimately what we get, xy is equals to c1. xy is equals to c1 that we can obtain. So this is your u. U is equals to c1 that we obtained. Now as we know, we are applying type 2, so that can be applicable here. So now we select here the first and last fraction. So by selecting first and last fraction, what we can get here, one x will be cancelled, so it will remain x cube. So it will be z square plus xy. And you know in the first solution, xy that we have obtained what? Xy is equals to c1. So that can be applicable. So now by having the cross multiplication, what we get, x cube dx minus z cube plus c1z dz is equals to 0. So this is now integrable. It is clearly, you can integrate it here. So it will be by integrating, what we get, x to the power 4 by 4 minus z to the power 4 by 4 again minus c1 z square by 2 is equals to some variable c2 or 2c2 that we can take. So by taking LCM 4, it will be written like that. By taking the LCM 4, and that 4 can be go into the right hand side. So the right hand side, that C2 that we can compare. So in this way you can get the second solution, and this solution U and V can be combined, and that will be the final solution of the given question. So we have two solutions, xy is equals to c1, and this is the second solution that we have obtained. So this is u, this is v that we can treat. So the final solution what we have, phi xy, that is u, and this is your v, x to the power 4 minus z to the power 4 minus 2xy z square is equals to 0. Phi being an arbitrary function. Now we go to the next question. Very quick, we can see now here your question is xyp plus y square q is equals to zxy minus 2x square. So capital P is what? Xy, capital Q is what? Y square, and this whole term, that is what? R. So again subsidiary or auxiliary equation that can be written as dx upon capital P, that is xy, dy upon capital Q, that is y square, and same way dz upon r. zxy minus 2x square that we can write. So very quick, we can see the first two can be taken, y will be cancelled, dx upon x, dy upon y, that we can obtain here. So by considering first two fractions, what we get, dx upon x is equals to dy upon y. Now you can integrate it. So by integrating, what we get, log x minus log y is equals to log c1, and by arranging, you can get x upon y is equals to c1, or x is equals to c1y, that you can write. In this case, what we have obtained here, x is equals to c1y. This is your x upon y that you can consider as a first factor. Now we can consider here, okay, now we can consider here the last two fraction. So by considering last two term, what we get here, and also we put here x is equals to c1y. So by putting x is equals to c1y, what we get here, dy upon y squared, and it can be written as dz upon c1 z y square minus 2 c1 square y square. So y square will be cancelled. So only, and c1 that you can take common. So c1 dy will be there, and dz upon z minus 2 that we can have. So now by integrating, what we get, it will be what? Okay. So z upon dz upon z minus 2 c1 square that we get. So by integrating, what we have, c1y minus log z minus 2 c1 square is equals to c2. Again, you can rearrange it. So by rearranging, what we get, x minus log z minus 2 x upon y square, because c1 is x upon y, is equals to c2. So in this way, we can get the second solution. So by obtaining this first and second solution, our final solution, the required solution for the given question is what? This is u, and this you can write as a v. So phi ub is equals to 0, that we obtained. Okay, so now come to the next point, next question, that we can very quick, we can go for the next question. Xzp plus yzq is equals to xy. So its substituted equation will be what? Dx upon xz, dy upon yz, and dz upon xy. Any two that you can pick, suppose first and two terms that you have taken, so z will be cancelled, and it will be dx upon x is equals to dy upon y. Again, you can integrate it. So by integrating, it will be log x minus log y is equals to log c1, or again xy upon c1, or x is equals to c1y, that you can write. So this relation we are going to use here. So again, first and second, that a fraction we have already considered. Now we go for the last two term. Suppose last two term we are taking here. So y will be automatically cancelled here, but x is equal to c1y, that we can see. So it will be dy upon z and dz upon c1y, that we can write. So c1y, that we can go this side, and z that we can go this side. Cross multiplication that can be applicable. So it is c1y dy, and it is z dz. So by integrating in simple manner, it will be what? C1 y dy will be y square by 2, and z dz will be z square by 2. So 2 LCM that you can take this side. So it will be c1 y square minus z square. Also we have to get back here. So c1 y will be x. So it will be xy minus z square is equals to c2. So this is the second factor v that we can see here. So now the final solution that we have here, xy x upon y, that is u, and xy minus z square, that is v, is equals to 0, that we get as a final solution of the given question. So I hope so. This makes you clear about the solution of such type of differential equation, partial differential equation using Lagrange type 2. So few questions I put it here. You can go through this. You can find the solution. If you face any problem, definitely you can write to me for the solution. I hope so you can get this solution after watching this full video. So all 4 questions that you can pick here. Okay, total 5 questions are here. Thank you for watching this my video presentation. So I hope so you enjoyed. Thank you.